Gravitation, or the force of gravity, is a natural phenomenon by which masses are brought towards one another. Since gravitational force is inversely proportional to the square of the radius between two object centers, more separation distance will result in weaker gravitational force. English mathematician Sir Isaac Newton discovered this when he was sitting under an apple tree and suddenly got hit in the head with an apple. This event led him to his law of gravity. Newton's law of universal gravitation states that a particle attracts every other particle in the universe, however, is directly dependent upon the masses of both objects and inversely proportional to the square of the distance that separates their centers. By this great discovery, Newton created two equations that calculate the force of gravity. The first being that the force of gravity is the mass of the object times the gravitational field. This equation applies to objects at the surface of the Earth. When the object is not at the surface, we use this equation. M is the mass of the two objects in kilograms, g is the gravitational constant, which always has a value of 6.67 times 10 to the power of negative 11, and r squared is the square of the distance between the two object centers. The normal force is the support force exerted upon an object that is in contact with another stable object. Imagine a skater on ice. The force of gravity, as we mentioned, pulls the skater towards the ice, but clearly there is some force at work preventing the skater from crashing through the ice and continuing to the ground. The force responsible for keeping the skater up and preventing the skater from accelerating downwards or upwards is the normal force. When calculating an object's normal force, when the object is at rest or not accelerating up or down, use the formula N equals m times g, m being the mass of the object and g being the gravitational field. However, we always need to remember that the normal force is perpendicular to the surface that an object is at contact with. Friction is the force that opposes the motion of an object. Different surfaces have a different force of friction. Friction is in a direction parallel to the plane of the interface between objects. For the simple example of a book resting on a flat table, the frictional force is 0. There is no force trying to move the book across the table, so there is no need for frictional force because there is nothing for the frictional force to oppose. However, if we try to slide the book across the table, friction will come into play and will affect the object depending on the surface of the normal force. To calculate static friction, we take the coefficient of static friction and multiply it by the normal force.